Okay, so hello everybody. I am Heather Lim from Team 12518 Alma Robotics. Today I will be introducing our special guest, Peter Hu, for the following workshop. Peter is the Chief Technologist of the University of Maryland Shock Trauma Center. Today we're very fortunate as he's willing to share some of the experiences he's had with dealing with coronavirus patients and how he used technology to solve these problems. This topic fully embodies the missions of FIRST, which is to apply what we learn to solve real-world problems. And today we get the chance to learn how to do that from a real professional. And without further ado, thank you, Peter. Please take it away.
All right. Well, thank you, Heather, for the invitation, and good evening, everyone. I'm certainly excited to have an opportunity to share some of the experience that we had in our hospital by using the robot. I'm not a designer. I'm just one of the users. So the topic of today is robot applications in COVID-19 epidemic. And I will briefly introduce to the group that our state of Maryland aromatic transport system and the trauma emergency systems. So these are, we have quite a bit of patients from the helicopter, from the ambulance they're sending to us. And then I will more focus on the telemedicine application. And in this case is the robot applications and in the COVID epidemic. Then we follow up with the questions QA sessions. So, okay, next slide. So, so state of Maryland, as you may know, have 6 million people around, 23 counties and 1 city, that is the city of Baltimore. In terms of emergency medical care, we have 5 different regions that here highlighted into 5 different colors, because not every county have a need to manage all of their 911 calls. So we separate into 5 different regions, and we have 11 helicopters strategically placed into 7 different locations across the state of Maryland. And the furthest ones are on the Western Maryland. The flight time from the Western Maryland to our Baltimore Shock Trauma Center is about 41 minutes. So this is the helicopter that it's a 3rd generation. We purchased 5 years ago with the money that you guys provided for us in your parents' tax. And so this is the AW130. It has 150 knots. The majority of the tasks for flight is for medevac. So the medical transport from the scene, that is when the people have a car accident or other major illness. And that's the 90% of the flight is for medevac. Then followed by the law enforcement, search rescue, homeland security, and the disaster assessment. So in addition to the 11 helicopters, this is again, this is a 5 region as we displayed. So we also certainly have to have hospitals that are taking care of the emergency care patients. So the state of Maryland have overall 48 hospitals has a ED, emergency department, to be able to take care of the emergency patients, and about over 500 ambulances, 5 trucks that could help us to transport patients to the hospital. So when the patients come in to us by either helicopters or by ambulance, this is our newest built Shock Trauma Center, Maryland Shock Trauma Center in the city of Baltimore. We have 2 buildings like this. And this is the only one trauma hospital freestanding buildings in the United States. So we're talking about a major trauma. Either people had a gunshot wounds, and actually we just had one this morning, and also a major car accident. And then they send it to us. We treat about 8,000 patients a year for trauma. This is not just an emergency. We also have another 60-bed emergency room for the University of Maryland medical system, medical hospitals. So when you're coming into our trauma center, you will see a sea of pink people. Either the male or female doctors and nurses we all wear pink. I can explain to you why in the QA session if you're interested. And more likely, when the patient gets into our trauma center, you will see Dr. Scalia on the left. And he is Thomas Scalia, we call him the boss. He's the chief physician of our trauma center. He also the previous president of the American Trauma Association. And he's also a chief critical care doctor for the entire University of Maryland medical system, consists of 14 different hospitals across the state of Maryland. So this is a very quick overview of quick overview of the trauma system. And this is what we have for specifically for the COVID. I pulled this one off about a day ago, last night. We have over 5 million people worldwide have a COVID positive. And in the United States alone, we have a 1.6 million people, unfortunately, tested positive. And further, more unfortunately, over 96,000 people died in US alone. So then we will look into our state of Maryland. So that the top one actually is New York, the green one. So our Maryland in the top 5 or 6, which is not too good place to be actually. And you can see that this is a daily, how many patients it's positive. And we're not really coming down. We go up quickly, then plateaued. Now, of course, it could potentially contributing to more testings. Of course, when you have more testings, you may find a more asymptomatic person. And this is the state of Maryland. Again, we have 44,000 cases positive. And very unfortunately, we have over 2,000 patients died in state of Maryland. But I can tell you what we are interested more is this black line. This is a current hospitalized patients. And the orange line is a regular acute care, not ICU. The purple is more important, that's ICU. So you can see the purple does not change that much. This is reflected in my observation in our hospital as well. So it's overall hospitalization going down a little, but the ICU still stay there at the plateau at the top, not coming down dramatically. Okay, so some very basic, very quick of COVID-19. So what do we know about this COVID-19? This is RNA virus. It's a part of the family of coronavirus. It's like some of our common cold. It's like SARS or MERS. And actually, the name for the virus is called SARS-CoV-2. Now, everybody knows called COVID or COVID-19. This is a clinical name. The clinical illness we call COVID-19. So in our hospital, it is the COVID positive, COVID negative. So this virus is attached to the ACE2 receptor. And ACE2 you can find in the lung alveoli. This is where they exchange with the blood to get oxygenation into the blood and get the CO2 out of the blood. So and also it happens to be on the heart muscles and other areas as well. But the mainly it starts from attacking the lung. So this is where it becomes quite a challenge. So as by now, I hope everybody knows the reason you stay home or we have all these potential opening phase 1 to 3 is because this virus is very contagious. So they transmit through droplets, airborne, and the surface. And this is a study that done with the Diamond Princess, the cruise ship way back. So it has a 10% household attack rate. That means that if you have one person in the room affected, more likely that 10% of the other people will get affected. The R-nuts, probably you may heard about it. This is it's a 2.3. This is where one person got affected. More likely, if you don't have a good protection, you will causing 2.3 people get affected. This is exponential. This is where at the beginning, we're thinking about, let's say 6 weeks ago, every 5 days, you double the number of patients that is positive. So what can we do about it? If we're still this high, that's really concerning. You definitely will overrun our hospital. So that's why we do stay-at-home orders. We do social distance. We need face masks when we go out. But for the doctors and nurses in our hospital, we have to do furthermore. Think about Dr. Fauci that a couple of weeks ago, due to one person in White House that COVID positive. And what does he do? He self-quarantined for 14 days. So you think about our hospital, we know the COVID patient coming in. Right now, it's close to a little bit less than 100. So if we don't do protection, to me, probably half of the people working in our hospital have to stay home for 14 days because they are there. And if we're not protect ourselves, then we have to do, each one of them have to do 14-day quarantines. That looks like maybe we won't have to work 2 days a month. So then who's going to take care of these patients? I'm sure we're not going to let that happen. So that's why the PPE becomes important, personal protective equipment, that including PAPR. So this is the powered air purifier respirator, which is this one, that you have a power, and then you push the air into the mask. So the doctors wear these and they go to the patient care areas. The N95 for different masks, including face shields. So these are the things that are absolutely important for us to wear to taking care of patients. So that's actually protect us, but also create a challenge of us to taking care of patients. So think about now you have to have a plastic over your face, you have face masks, you have 2 sets of gloves. So all the regular feelings are different. You're making your working less efficient. Okay, so now coming down to this group, which is a STEAM group, you guys are all expert in building robots. So what do we do that related to telemedicine or robots or technologies in the hospital? So, and the purpose is for us still, we really want to do the best care for the patients, but reduce exposure for care providers. And here's nurse and the doctors, including the other cleaning crews and supporting staff. And right now, we separate patients if they're positive, if they're in ICU. Let's say ICU have a 16 bed. We're blocking that area. We make a negative airflow so that the airs do not coming out of the area contaminated the other side. That we call that's a hot zone. And if the outside, we call cold zone. So the people to go into the hot zone from the cold zone, we have to do donning and doffing, putting on all these protective gears. So, but sometimes, let's say normally if I'm in a nursing station, I forgot my notes in the patient room. What do? I get up, I walk, and push the door open, like here, and another door, then go into the patient room, say hi to the patient, take the notes, coming back. That's a 5-minute thing. So right now, if you want to do the same thing, if you are in the cold zone and the patient in the hot zone, you have to do a donning, which is putting all protective gear on. That's about 10, 12 steps. And you have to do a doffing, it's about 15 steps. So just taking something out of it, just my notes, it will take about 30 minutes. So you could see that add inefficiency in addition to try to reduce exposure. So we did 3 things. So one is we bought a few hundred iPads. So we keep the iPad in the room, and then the nurses can communicate with the nurse outside to say, I need this, I need that. So the next group of people coming in can bring in for them. Secondly, is they can provide a nurse to clinicians communications, including when there's surroundings and there's any questions from doctors to the nurse. And they can provide the patients to their family members. So very unfortunate in this case here, that in this particular disease, that the patient families are not be able to see them in the ICU physically. So that this provide another way to do that. And the software we're using, it's very interesting. It's the same software that I'm talking to you, Zoom. So we had a few hundred of these. Each patient has a pair, one inside, one in the cold zone. And furthermore, that we build up a interface to bring patient vital signs to the outside, so we can look back 5 days, and we look at every changes. Are they going up? Are they going down? Are they in the reasonable range? And the last but not the least is medical robots, which is here. So these are just few pictures. This is a doctors, nurses inside the room. They're all face covered and completely covered with multiple gloves and talking to the clinicians outside. This is a robot that we bought 6 of them. We just put it in a couple of weeks ago. 5 of them in our COVID ICU rooms. This is the one that actually is outside of COVID ICU room. It's a multi-trauma ICU room. And the reason is at least you can see their faces. Otherwise, they all will be completely covered. You wouldn't know who's who. So, but this is a robot that we used in our hospital. This is the 5th floor, actually 6th floor is our COVID room. Okay, so for this talk, I tried to see how many other things that people use medical robot. I went to the Wikipedia and I see there are many different things that people are using robot for. There's surgical robot, like a Da Vinci, so they were helping the remote clinician surgeons to do operations, rehabilitation robot, bio robot. The telepresence is the one that we're using here. Also, a pharmacy, they're doing the automations using robot to mixing the drugs also. So I provide the link here for you in case you guys are more interested. So then when I look at it, why do we need a robot? Why don't we need a robot before? So in addition to, we try to provide the communication capabilities. So since we have iPad, so why don't we just have a nurse in there pointing iPad to the areas that the doctor wants to see? The potential challenge is that the doctor may want to see different places. So you expose the nurse inside the COVID patient room just as moving around the camera. So that's one of the things we think the robot will help, that the nurse don't have to be physically there. Of course, when they need it, if we do some examinations, of course the nurse will be in. Furthermore, it is very expensive to developing a clinicians we call intensivists. Those are the doctors that are certified to run ICUs. And some of them are above 60 years old. And themselves, in this disease are considered to be high risk. So, and then how we protect them? What we don't want is we don't want to running out of those experienced doctors. And then who's going to take care of our very sick patients? So these are so-called under the need assessment. Because we have needs, that's why we select the robot. And then what kind of robot? So we're looking into the functionality. Could robot move around? Does it all require people pushing around? Could it do automatic? If I say can you go to the patient bed number 3, it will go by itself instead of, how can I do that? So if everything requires joystick control, sometimes you are not physically there. You may, by accident, be hitting something. Can the robot avoiding these? So it's a safety. You don't want to drive the robot all the way, high speed, heading the patient bed and then flip. What about user interface? With all respect to the doctors, they're not computer scientists. Don't tell them there are 30 different buttons. It's all in one screen. And because you designed it, you know which button to click. But they may or may not know in the heat moment. And the last not least, the fancy words called return on investment really is the cost. Is it worth it? A robot like this, it may cost around $80,000 to $100,000. So where do you get a return on the values? Those are the considerations that I could think when we select these robots. Okay, so some of the few quick images that happen in our trauma center. So this is doing the downings, and the doffing is the same procedure. You have people that really direct you of how to do that. You're putting the protective gear on. This is where that you're from the cold zone. The middle is a warm zone. When you open this door, inside is the hot zone. And this is how the clinicians inside the patient ICUs are doing procedures. And this is, we know that the patients that this due to lung injuries. So almost all the patients in our ICU right now, it's like 65 of them all on ventilators. But the ventilator, which is push enough oxygen, the high concentrated oxygen to the patients. But if the lung function is got really impaired, they still cannot exchange the oxygen through the blood. So then the last result, we use this ECMO, extracorporeal membrane oxygenation. So this is where you got the blood coming out, and which is dirty blood or with full of CO2s. This machine exchange, get a fresh oxygen and coming back and send it back to the patients. So it replaces the lung function. And then the same machine actually also have a capability to replace the lung and the heart. So this is the last ditch effort. And we actually right now have more than 15 patients that are on ECMO in our hospital. All right, so with that, let me show a couple of the videos. Now, due to the patient confidentiality, I am not be able to show you the real patient right now in our ICU, but I can show you the functionality of the robot. And also I pick another one, which is the drug delivery robot. There's two different robots. So it's two videos. Let me see if I can stop sharing this. I share the video for you. Okay, let's see, it's right here.
High tech.
All right, Ms. Prince, I'm Dr. John.
Thanks to these robots introduced in hospitals across California and some other US states, doctors are now able to beam themselves into patients' rooms and offer medical advice. The physician can log into the device by using a computer, laptop or tablet. A two-way video system allows the physician and the patient to conduct a consultation. The robot has an auto-drive function that allows it to navigate to the patient's room using sensors to avoid bumping into things or people.
That it allows for very quick evaluation of these patients. So it's just like being with the patient in the room. So of course, you know, nothing could replace seeing these patients in person, but it's the next best thing.
A growing number of hospitals are using remote presence robots to expand access to medical specialists, especially in rural areas where there's a shortage of doctors. The physician can't touch the patient, but there's always a nurse or medical assistant on site to help if needed.
I think that the technology enables us to be virtually present in the clinical environment. There is a limitation in our inability to touch the patient, but as far as a clinical evaluation, taking a history, making a really good clinical decision and making sure there's the best outcome for that patient, I think it's very close.
While the advantages of using these robots are undeniable, especially in emergencies, critics are pointing to the high cost. Others have also raised security concerns over potential leaks of data gathered by a remote-controlled device crawling around a research laboratory, for instance.
Okay, let me share with you another robot that we used to use about 5 years ago to deliver the drugs to our ICU patients.
Robots are pulling their weight inside the Pittsburgh hospital. There's more than just patients and staff walking the halls. Say hello to Tug, an automated delivery robot designed to move medical supplies, linens, and even patients' meals around the hospital.
Aethon has developed this technology. It's an autonomous mobile robot. It's a robot that can travel inside a facility on its own. It does not require the infrastructure that other types of vehicles might require in order to navigate. So it's completely autonomous. It can travel down hallways, communicate with its environment, ride elevators, open doors. It's a very efficient and affordable and reliable technology that we've developed for the internal logistics, if you will, in facilities, particularly in hospitals.
The system uses software that allows both scheduled and on-demand delivery, letting end users like doctors and nurses place trays within Tug and have them transported throughout the building.
The robot utilizes a variety of sensor modalities, laser scanners and IR sensors. In order to sense its environment, it knows where it's at.
Fitted with a biometric fingerprint scanner and capable of carrying more than 1,000 pounds at a time, the machine's no lightweight. But that doesn't mean he can't play well with colleagues.
As the robot navigates through the hospitals, it does make people aware of what it's doing. So there are certain voice commands that it will say as it travels. If somebody gets in its way, it'll kindly ask them to move aside. As it's waiting for an elevator, it'll tell people it is waiting for an elevator. But the technology really tries to work within the institution.
And whilst Tug might lack the human touch, you'd be wrong if you thought that would prevent it from storming other markets too.
When you think of all the things that move within a hospital today, it's quite inefficient. It's done very manually, as it's always been done, people pushing carts. Today, there are over 400 robots that we have actually installed here in the United States in over 100 hospitals. And we're beginning to get a lot of global attention as well. We now have robots operating in Europe as well as Australia. We're going to continue to grow globally with this technology.
And what about the cost of Tug and impacts on existing jobs? The company says that's really not something most organizations and even employees will worry about.
There are definitely applications where robots are more suited for the work than humans. You really want to use robots in jobs that people don't want to do or people can't do or really people shouldn't do. So when you look at people pushing heavy carts, do you really want them doing that? Probably.
Okay, so let me just stop here. And so let me stop sharing on this one. Let's see, I share my other screens for the group here. So we went through the demo of the robots, and I provide the list of some of the other things I found on the web, the robot in medical use. And if people have interest, this is a Da Vinci that actually we also have several of them. They use remote surgeries, and so these are all different lists. At the end, I want to thank you for Heather, for this opportunity to talk to your group. I'm so glad that we found a pink doctors with a pink smart people together. So, so now I'm ready for answer any questions. Thank you.
So I will take over your screen and display the question.
Sure. So, okay, so the first one, is it possible to make a mobile trauma center in helicopter or trucks? They could carry all the supplies in the helicopter to use a box truck. Let's see what you try to, so does that, so trauma center, to make a mobile trauma center, it's quite a challenge. DoD have something called forward deployable hospital. These are the field hospitals that in this COVID time that helping a lot of states to set it up. And in helicopters, we can carry all the supplies. So I could see that in the deployed field situation, if you have a Wi-Fi, the tugs or the mobile unit could do. I think if I'm looking at the mobile, the robot-based systems, there are certainly two options. One is the mobile platform, the things that has to be moved. It has to be solid and could finding a place. Let's say you set up a place A to place B. A is your base. B, let's say, is room number 3. So you don't have to use a joystick to control it or use computer to control every time by humans. The robot could get you there. And the second is the robot has to do some functions. You know, does it deliver things? Does it carry a cargo? And does it, in this case, in our current robot, does it provide a high resolution cameras? So you could look around and assess patients. So those are the functionality of robot. I do not know if I answered that question. You can have a follow-up on what you mean by that. So the second one I see is, why don't we use nanotechnology to help the patient? Well, that's a big question. That's I think some of the nanotechnology certainly could use, but I'm not an expert using, I saw some futuristic plannings. I do not know, maybe it's out there, that people really using nanotechnologies. Right now, let's say you're talking about deliver drugs to the patients. There are some saying that Hopkins use, not nano. They have a pill that could measure your temperature inside, so you can swallow the pill. It goes through your body. Let's say 4 hours later, it's coming out of it, but it could transmit the core temperatures or the other issues that when it goes through your system. So let's see what's next. Why don't we make people who have COVID virus become doctor nurses? Then we won't need to use as many medical supplies. Good question. So I have 2 potential challenges. I think making someone to become a doctor, based on my understanding, it may take more than 10 years. So we have very short time frame right now. To making someone even become a nurse assistant is not enough. And furthermore, the challenge is when they really get into ICU, themselves are so sick. I do not know they're capable at this moment of really high learning. I'm sure some of them are. But thank you for thinking about it. We don't have to wasting the PPEs. Instead of robot that driver stuff, why don't we use drones instead? Very good question. June, you're talking about the fly unit. Actually, last year, University of Maryland, our trauma centers, working with College Park, using the drone to transport, I think, a liver from the donor, fly to our trauma center, and we successfully did a liver transplant. So it is certainly possible, but robot does I think we have more challenges. I think if you have a drone has to be stable in a place, and we probably have more wires in the air sometimes. Think about IV lines and ECG cables. So, and if you fly near patient head, if one of them hit a wire or so, if it fell down, it could be quite a bit of challenge. So, but it's a good thought though. If we have a stable drone, that would be very interesting. Why the trauma center use pink colors? Okay, so this is something to do with the original trauma center when we designed. We actually very poor. We spend all the money to build our buildings. We don't have too much money to buy many other things, and including the scrubs. So that at the time there's 3 choices: green, blue, and pink. So we select pink. So if anybody wear our pink dress, we can tell them, come on, give back to us. This is ours. So right now, the trauma center is one of the best in the United States and in the world. So people actually coming here to buy our scrub for a cost of $50, and you put a screen on, it's well over $100. So when you make it number 1, everybody want it. But before that, unfortunately, it's due to the need of, we just try to keep our pink scrub for ourselves. So we have another hospitals next connected, the University of Maryland Medical Center, and also we have VA. So those are the original reasons. Can we fly tiny drones in people to helping them? Good question. I think in people meaning you get into it. So I think there's a potential, but it's sometimes away. How affordable was the tug robot? That's a great question. So I mentioned we used it about 5 years ago. So we started about 10 years ago. And we used it for 5 to 6 years. And I think 3 years ago, we decided that we're not going to get a new version of it. It's at the beginning. I think we have up to 6. For 6 of them, we can save about 1 FTE, meaning a 1 person. So, but you have to do a lot of support. Wireless have to be available. The beauty of Tug is can call the elevators by itself. But you can see that when things does not working, you not only you have to involve ITs and many other reasons. So at the end, it's not the device is not good. It is the return on investment. It may not be. This is my own personal view. So right now, unfortunately, we're not using them. We used up to about 3 years ago. Is your university doing anything to COVID prevention? Absolutely. You can see that some of my images. I have my face mask on. I have my N95 face masks. I have my face shield to put on. So when I go in, I will get my pepper before I get into the ICUs. So protection is absolutely important for us. Can robot transmit virus? Very good question. The reason we buy 5 or 6 of them is we keep 1 in each COVID ICU rooms. So if I'm not disinfecting them, I will never allow them to coming out of that so-called hot zone. So yes, if we're not disinfecting them, in theory, absolutely they can transmit virus because they have a virus. They're in the environment. So what are some of the things the robot can do to diagnose patient? Great question. So the robot on the side has a stethoscope that you can connect, and you can use the stethoscope for the remote doctors that at home, they could hear from the headset of the patient stethoscopes. They also have a video input, a different type of video input. So you could see the ultrasounds, or they can also send an image. In addition, the doctor at home, they are not logging to, in addition to logging to robot, they will log into the patient record system securely through the VPN. So they could also see the x-ray, the medical history, independent of the robot. So this is how, and in addition to the vital signs, remember we transfer vital signs in real time, so they can also see at home. So they have a close to total visibility of the patient conditions. So why can't we print more money to buy more helicopters? Well, I guess as you can see that if you print more money, somebody have to pay for it. So that there's a cost of balance, and running a helicopter is not cheap. And so do any other hospital use robot for COVID? Yes, there are a few other hospitals that are using robot as well. Would it be a good idea to sell part of the hospital by more robots? That may not be idea because the hospital has a need. And if we sell some of that, and then where are the patients go? So that may not be the best idea. The best idea, I think, is we're working with all of your guys to social distance, have less COVID patient coming to us, and then we can take care of these situations. Because in here, we also, at the same time, we have to treat cancer patients. We have to treat the stroke patients. It's not something that we have no patients other than only the COVID patients. Do your robot have infrared heat? Yes, it has infrared sensors. Heat sensor I have to see, but they do have cameras. The Tug, the one that go around the hospital to deliver drugs, it has 30 some cameras in the bottom of it. Now, when I say deliver drugs, actually deliver non-narcotic drugs. Narcotic drugs still have to use a human to deliver across a hospital. Have your university made any robot for COVID, that is? Great question. I do not. So we are in the School of Medicine in Baltimore. We don't have the engineering team. Now, College Park and UMB do. So I don't, as far as I can tell, I do not see any robot made by the University of Maryland at this moment. Can you elaborate on why you work? I missed the beginning. Why? What do I do? So I'm a chief technologist. I am also a associate professor for anesthesia and surgery doing clinical research. But my current role for talking to you is I'm helping them to, I am a biomedical engineer in training. So, and I helping the hospitals working with the biomedical team to provide a remote access for taking care of this, the COVID patients in this particular speech here. What do need to improve after you have some experience using robot? That's a great question. We just started. Certainly, I could tell you right now, due to the network issues, the robot running very smoothly at night. And during the peak time, let's say, especially in afternoons, the robots sometimes have some issues when we need so-called multi-presence. Let's say I want to invite 3 different doctors or video coming in to see the patients. And then you experience a slowness. So that potentially could be, can we have a better compression algorithm for images? Can we have a faster network? Can we redesign network? So there's a lot of logistical issues there. What can young people like us who are stay home do to help to affect against COVID? Okay, so first thing is follow the rules. If we have a stay home order, please do that alone. You're already helping us. So that either you don't contract virus and God forbid, if you have one, do not send to somebody else. Wear face masks, social distance, and then study. Like you listen to me, I hope that I could encourage you to spend time, if you're interested in robots. There are a lot more features. I think after this COVID-19 episode, more and more technology, especially telemedicines, will be used in the medical field. What are the regulation use robot for? That's a good question. Certainly, for now, this robot actually not just being built. I used one of the early versions about 10 years ago. I think this robot company existed about 20 years. So they certainly have regulations. I have to see what are the specific regulations that I think they have some kind of FDA approval, but I have to see how, this is a good question. I have to see, do we have additional requirement for selecting robot? Because it's a robot that we're not only the first one using it in the hospital. Do you think that a robot may use for application other than, well, regularly people also using the robot. Just using 2 examples. There are many different robots. They do remote surgeries. They could also greeting patients when you're coming into the room. I saw one in one of my reference. I will give it to you later. That people just are greeting patients, tell patients, could you please wash hands? So you do not have to have a lot of face-to-face possible transmissions. What are the chances of catching COVID if you went outside with no mask and went to a market with upwards? This is a good question, though. Certainly, you catching it as a few things that to me. One is, of course, you have to have people who is COVID positive around in that area, or they've been there, or they coughed or something, they touched on the surface, and then somehow you touch it. And then not only you touch it by hands, then somehow you manage the hands to touch your face that eventually gets into your nose, eye, or mouth. So those are the ways. This is where the people asking us to wash hands. I forgot to say many times, washing hands. One of the reasons that washing hands will help is not necessarily the water, it's the soap or the alcohol-based, because this coronavirus, as far as my understanding, they're surrounded with those oily bubbles around it. And the soap where it can dissolve the oil and break down the virus. So you need to put a soap on and for 20 seconds, and it is 7 steps of washing hands. So that will helping you greatly, even you touched it. Your chances are there are many different studies. It depends on the situation. But have yourself protected, hands, face mask, and so those are the things that are absolutely important. Social distance. Have the robot being able to contact the family to the patient? Great question. And right this moment, we have not used a robot to communicate with patients because we already have the iPad unit be able to letting family member to talking to the patients. Why did the hospital stop using TUG? It's due to the return on investment. So I think a couple years ago, probably the older TUG is already to their full use age. If you buy a new TUG, there are additional cost. And so it may not be economically, I could ask, but that's my observations, sound to run another new group of TUGs. How long can your robot work for one child? That's a good question. I think it mentioned that around 10 hours is the current one. And the good thing is that on the button, they say home. So you can go to, actually they will, when you finish using it, they will find a ways to go back to home. That home really means they can charge themselves, connected to the power source. So, all right. I think I managed to answer most of your questions. Hopefully that's what you're looking for. How many years did you go to school? Oh, quite a bit. I think I go all the way to the PhD. So 10 years after high school. So a little bit less. So how advanced is the user interface? User interface, to me, more advanced is more intuitive, actually. If the doctor one of the doctors says, I want to see this, ideally, you're only showing, you can guessing what they really want to do. So showing them button selections are logical to their actions. You know, if they say, I want to see the patient face, so you relate it to, let's say, zooming functions, pen and tool functions. So those are the ones that more likely they will do next. So it is not easy, though. This is more of the human factor areas. And that alone, when you're designing, I'm sure you may facing some of that when you're designing your robot. That user interface, especially for other people to use your own software, it's not an easy thing. I hire quite a bit of PhD student, and it took me a while to convince them. It's not only they can run it, it's other people can run their software, which is different than they can run it. How much study did it take to get to where you are? How much study? Let's see, 4 years undergraduate, 2 to 3, 2 years, another 2. Yeah, we're talking about 7, 8 years if you do straight. It took me a while because I have a break in the middle. So I go to work, then I finally get my PhD. So there's a gap for me. So you're thinking about 4 years of undergraduate. It's, let's say, 2 years of master, then 3 years of PhD. So can I become a doctor if I drop out of high school? That's a good question. So then as a doctor have but you need to get into a university first. For any medical school student, the first class they took, they must have some kind of bachelor degree training. So it doesn't matter. You could be most of them are pre-med student, so you could be engineering. Actually, anesthesiologists actually have a lot of them have engineering training in their bachelor degrees. So you do need to get through the bachelor degree. Then you apply medical school. Then you have to pass so-called the MCAT test, which most of people have goes through a pre-med as well. Can I become a doctor? Okay, science.
So I think unfortunately we only have time for one more question, and then we'll end it here.
Okay. What are the type of medical robot? See my a list. I provide a list of like 5 or 6 of them already. Do you think the virus will die down during the summer? It may coming down a little bit. Unfortunately, the official answer is I do not know. Actually, nobody knows. But looking at Singapore, the other places, the hot place, the weather places still have a COVID, like India. So more like we're still having them around. And this is unfortunate, but that's what we prepare for. All right.
It just showed up on my
Thank
screen.
you,
Thank
Dr.
you.
Hu.
There's a delay.
Okay, well, thank you again, Heather, for the invitation, and thank you all of you guys that online